Hello friends, you are heartily welcome to Assist the Engineering Foundation. Today under Distributed System Day 4 we are discussing Distributed Computation Paradigm of Unit First. I hope you all are also well. So let's start. In the Distributed System Computation Paradigm, in this lecture we will discuss distributed computation paradigms. Distributed computing is a type of computing that divides tasks among multiple computers. These computers work together to solve a problem. Distributed computation paradigms are the different way that distributed computing can be implemented. So let's start of unit first, distributed system, and our topic is distributed computation paradigm. First of all, we discuss about the paradigm for distributed applications. A paradigm is a way of thinking about or doing something. In distributed computing paradigm are the different way that distributed applications can be designed. There are many different distributed computing paradigms, each with its own advantage and disadvantage. The level of abstractions of a paradigm refers to how much detail is hidden from the programmer. Low-level paradigms such as message passing require the programmer to deal with the details of network communications. And another is high-level paradigms such as the object space paradigm hide these details from the programmer. In the paradigm, a paradigm is a pattern, example, or models. It means in the study of distributed computing, it is useful to identify the basic patterns or models. The paradigms will be presented according to their level of abstractions. Message passing has the least amount of abstractions and the object space paradigm has the most abstractions. In the figure, top level is high level and below is low level. In the high level abstractions, object space, after that network services, object request brokers, mobile agent, and after that remote procedure calls, remote methods, invocations, and then client server models. And lowest level of abstractions is message passing. Next is the message passing paradigm. The message passing paradigm is the most fundamental paradigm for distributed applications. In this paradigm, processes communicate by sending message to each other. A message is a unit of data that contains a request or a response. The sender process sends a message to the receiver process. The receiver processes the message and sends a reply message back to the sender process. The message passing paradigm is a low-level paradigm that requires the programmer to deal with the details of network communications. However, it is also a very flexible paradigm that can be used to implement a wide variety of distributed applications. In this paradigm, message passing paradigm, process A and process B are concluded and each process communicate with each other. Next is client server paradigm. The client server paradigm is a popular paradigm for distributed applications. In this paradigm, there are two types of processes. First is client and another is server. Server are processes that provide services to clients, and clients are processes that request services from servers. The client server paradigm is a simple and efficient way to organize distributed applications. It is also a very scalable paradigm, as a single server can service many clients. Means simple and efficient abstractions for network services. And many services provided like internet services or client server applications, HTTP, FTP, DNS, etc. Next is P2P system architectures. The P2P paradigm is a different way of organizing distributed applications. In this paradigm, all of processes are equal. They can all act as client and servers. The P2P paradigm is a good choice for applications where there is no need for a central server. For example, it is a good choice for applications such as instant messaging and file sharing. Next is the message system paradigm. The message system paradigm is an elaboration of the basic message passing paradigm. In this paradigm, there is a special process called a message system that acts as an intermediary between the sender and receiver processes. The sender process sends a message to the message system. The message system then forwards the message to a message queue that is associated with each receiver process. The receiver process can then retrieve the message from its message queue at its convenience. The message system paradigm provides a number of advantages over the basic message passing paradigm. First, it allows process to exchange message asynchronously. This means that the sender process does not have to wait for the receiver process to receive the message before it can continue processing. Second advantage is it allows process to be decoupled from each other. This means that the sender process does not need to know anything about the receiver process, such as its address or its current state. Next is subtype of message system models. There are two main subtypes of message system models. First is point-to-point message model and second is publish subscribe message model. In the point-to-point message model, the message system forwards a message from the sender process to the message queue of the receiver process. This allows the sender and receiver processes to be decoupled from each other. The sender process does not need to know anything about the receiver process, such as its address or its current state. The receiver process does not need to be waiting for a message when the sender process sends a message. The point-to-point message models also provides asynchronous operations. This means that the sender process does not have to wait for the receiver process to receive the message before it can continue processing. Second is publish subscribe message model. In this model, each message is associated with a specific topic or events. Applications that are interested in the occurrence of a specific event can subscribe to message for that event. When the awaited event occurs, a process publishes a message announcing the event or topic. The message system then distributes the message to all of its subscribers. The publish subscribe message model is a powerful abstraction for multicasting or group communications. Multicasting is a type of communication in which a single message is sent to a group of receivers. The public subscribe message model is message to all subscribers, allow a process to multicast to a group of processes by publishing a message to a topic. Any process that is subscribed to that topic will receive the message. Another is MessageQ Services MQS. The MQS are software services that provides asynchronous messaging between applications. MessageQ services allows applications to exchange message without needing to know about each other's details. This is because MQS act as an intermediary between the sender and receiver applications. The sender application sends a message to the MQS, and the MQS then queues the message and ensure its delivery to the receiver applications. MQS offers a reliable way to queue messages and ensure their delivery. Even if the receiver applications is unavailable when the message is sent, the MQS will queue the message and deliver it to the receiver applications when it becomes available. MQS supports both point-to-point and publish subscribe message models. The point-to-point message allows a sender application to send message to a specific receiver applications, and the publish subscribe messaging allows the sender applications to publish a message to a topic. Any receiver applications that is subscribed to that topic will receive the message. There are many different MQS products available, including IBM MQ, Amazon SQS, and Microsoft Azure Service Bus. Next is conclusion of today's topic. In this lecture, we have discussed distributed computation paradigms. Distributed computation paradigm provides a different way to structure distributed applications. The choice of which paradigm to use depends on the specific requirements of the applications. The message passing paradigm is the most fundamental paradigm, and it is a low-level paradigm that requires the programmer to deal with the details of network communication. And it is a simple network communication, and the client server paradigm is a popular paradigm for network application. It is a simple and efficient way to organize distributed applications. The peer-to-peer paradigm is useful for applications where there is no need for a central server. It is a more complex paradigm to implement than the client server paradigm. The message system paradigm is an elaboration of the message passing paradigm that provides asynchronous and decoupled communications. It is a more complex paradigm to implement than the basic message passing paradigm, but it offers a number of advantages I hope this lecture has been helpful. Here are some assignment questions for you to practice. As first question is, what is distributed system paradigm? And second is, explain distributed computation paradigm in details. Thank you very much for watching this video. To see more video like this, please like, subscribe and share our channel with your friends so that you and your friends can also get the benefit of this video. See you in the next video with a new topics. Thank you.